Good morning, good afternoon, and hello to everyone at our next 30 minutes webinar. My name is Paweł Szarmański, and today with my colleague Tomasz Janicki.
Hello.
We'll present you the VAV14-IP controller programming. Our VAV14-IP controller is configurable, but also freely programmable controller. The built-in application can be easily adjusted and fine-tuned, but also can be extended thanks to the programming capabilities of our NanoEdge engine that is embedded into the controller. And this is going to be the topic that we'll cover in the next 30 minutes. If this is the first time you joined our webinar series on the VAV14-IP, we already had two introduction and a deep dive into the controller itself, as well as the built-in application of the VAV controller. So if this is the first time, you're welcome to go to our YouTube channel, and on the ISMA Control channel, you will find both of them available today. And before we go to the webinar, we would like to take this moment and thank to all the visitors at our booth at the HR Expo 2026 in Las Vegas. We had the opportunity to be together with Tomasz, and we were delighted with the discussions, all the conversations on the technical level, and all the insights we could give you on the new products. And we would like to also take advantage of the moment and invite you to the upcoming events. The first one in Italy, in Milan, which will take place on the 24th of March, will be at the MC 2026. And in April, on 7th of April in Washington, we will have an opportunity to be one of the sponsors at the upcoming Niagara Summit 2026. So see you at those events. And without further ado, let's go to the agenda of today's meeting. If this is the first time, we'll quickly go through the system commissioning overview of the VAV14-IP controller. We'll introduce you to the NanoEdge engine functions. We'll summarize them and tell you what exactly you can take advantage of when fine-tuning, adjusting, or extending the VAV system. Plus, we'll go through the main topic, which is a live demo of the controller programming.
So last time, in the last webinar, VAV controller deep dive, we decided to divide the commissioning of the VAV system into 5 basic steps. I want to quickly remind you how the process looks like. And the first step of this is to define your VAV system. Out of the box, VAV14-IP controller supports 216 different VAV box types. So the first step is to select your system. So you need to know what exactly we can support and what is achievable with our controller. To do this, you need to find the place that we inform about all those information. This is our knowledge base, which we presented last time. But you can find all the application algorithm, application variants, and the full description of the configuration. The next step is to configure the VAV14-IP application. Just to remind you, and for the new people, we've got 4 different ways of the configuration. The first one is using the deep switches. So using the deep switches, you can select the basic settings. You can select the reheater, activate heating system, and select if you have the fan in your application. You can also set the units, and this is all that you can do, the basic configuration of the VAV types using the deep switches. More advanced, but also very simple and very easy to do, is to configure the VAV box using the dedicated CP-VAV control point panel. The next two, they are the way that we are doing using the PC or laptops, so we can do it remotely, and we provide 2 different ways. The first one using free of charge ISMA configurator, free of charge tool. And the second one is for the Niagara users. We provide dedicated service, IC Device Manager, when you can do the configuration, balancing, and the flow settings on the VAV controller. The next step is setting the IP addresses. We also provide a dedicated tools, dedicated view to manage the IP address, because by default, the VAV14-IP comes with our default static IP. And all of them, if you do the commissioning, and you probably have more than one on site, you need to set the IP and assign it to correct space. To do this very quickly, we have got the IP manager. This is the dedicated view in our IC tool, where you can activate, deactivate the DHCP mode, or set the IP address for all discovered devices available on site. The next part is to deploy the parameters to your controllers on site. And for this is the same like the configuration. So you can use the remote, you can do it remotely, and you can use the ISMA configurator and its ISV device manager dedicated service in Niagara.
And last but not least, an optional, adjusting the control logic inside the controller. So the sixth step is the major part of today's presentation. We'll focus on that. And it's only available thanks to the onboard embedded NanoEdge engine, which is our software platform that will allow you to modify and expand the application. So let's start with the very basics. Our NanoEdge engine is freely programmable. We have two dedicated tools, a Niagara Workbench and IC tool. Inside the Niagara Workbench, we have a special extension you need to download, which is called AnyToolLink. You can also use our IC Workbench, which already includes the proper module to do the programming. The system is cycle-driven and can store multiple applications. We are native with Modbus and BACnet protocols, and all the data in the controller can be exposed over those protocols just automatically without any actual work needs to be done on the programming level. The system is modular. Our NanoEdge engine inside the VAV14-IP utilizes only the required modules, the required libraries. And if you would like to take advantage of another features that we'll go through, like trends, which are supported in our latest 1.8 version of NanoEdge OS, you can just freely install this library and just start working with trends. It is license-free. There is no license stored on this controller. The controller capacity is limited to a number of data points. And all the tools that we are providing for programming, configuration, are free of charge. So constantly updated and improved. This is what we are very in favor of to provide to our customers and partners. Every device, every VAV controller that has been purchased in the past will be able to upgrade with the latest system and application features that we'll provide in the future, free of charge. So let's now look at the actual application inside the VAV controller from the NanoEdge engine system perspective. There's one application built into the VAV, but as I mentioned, we can build multiple time deterministic applications inside the VAV controller. So let's have the second application and just call it a custom application. We can run both simultaneously on a single controller, and those applications, they can run independently in their own time cycle. And this is per the application requirements for the application. So the built-in VAV application scan period is set at 200 milliseconds. For the custom application, the scan period can be even lowered up to 100 milliseconds, but of course, per the application requirements, it can be set at 1 second, at 10 seconds, or even 60 seconds, just to save some memory capacity on the controller. But it's up to the application and up to the engineer of the application to decide of the scan periods. In the application container, the components that can be used, stored, copied, and utilized are equipments, folders, data points, and all the logic that we'll build inside those containers. And what is the capacity of the custom application if you decide to build one for the second and third apps you would like to build? The total capacity of the VAV controller is 150 data points, and our built-in application utilizes 116 data points out of the total capacity, which means for any custom application or expansion of the built-in application you would like to use, are 34 data points available. So it can be either another custom app or two custom applications where we divide 14 data points for the first one and 20 for the other one. Or we can just build on the top of the first one. It's really programmable environment, and we give all of those options to the engineers to take advantage of them and build a better system for the customers. What we do in our NanoEdge engine platform is we support haystack ontology. When you look at the built-in application, all the data points are stored inside the equipment container. And those equipment containers are also visible over the haystack protocol along with the data points, which means that the site, which would be the supervisory software, can visualize or integrate all of those data directly from the controller once the haystack is enabled. And at the end of this webinar, we will tell you more about the upcoming features, including the haystack support. So stay until the end and learn more. And if you look at the supported functions of NanoEdge engine, next to the Friedel programmability and next to the expandability with libraries, we support different protocols. So you're able to integrate over the onboard IP or RS485 port and expand the local I/O number over BACnet or integrate any network equipment. We support BACnet as a client and server on both MSTP and IP layer. That means that the VAV14-IP can be even visible on the MSTP layer if the user decides to wire the application as such. Moreover, we support Modbus RTU and Modbus TCP/IP as both client and the server, which means you can integrate network actuators, energy meters, or our I/O modules. As you may know, our I/O modules are multi-protocol and support both Modbus and BACnet protocols. So all of that can be integrated over, all of that equipment can be integrated over Modbus RTU or IP. Additionally, we also support a Modbus TCP/IP to Modbus RTU gateway function, which means next to the integration, all the Modbus RTU devices can be transparently viewed in the supervisory software on the VAV14-IP IP address, thanks to this transparent gateway function. What's more, we support schedules. And the schedules include support for the special events and calendars, which are, again, natively exposed over the BACnet network, which means any custom logic that is being built inside the controller can take advantage of those special events to set the values locally and be later synchronized with the supervisory software to set them over such, for example, Niagara Workbench. And last but not least, the latest function that has been added to the NanoEdge OS 1.8 are trends. The trends, as when configured on the controller, are supported on any data point available already in the system, which means the default application can also take advantage of that. But as well, all the custom data points added to the system can be enabled with the trend extension. The trend extension is also available and exposed over BACnet network to be stored and visualized in the supervisory applications. In our Nano HOS, we support interval, change of value, as well as a mixed interval COV support on the trend log data. And now the main topic, which is customizing the controller logic.
So today we are going to not only go inside the PowerPoint presentation, but we are going to make some changes in the logic. By default, VAV14-IP application supports connection of one dedicated space sensor. We have a control point panel, which can be connected using a dedicated smart plug socket, which transfer communication and power supply using one cable. This is the capabilities of the default application. So today we are going to connect the second CP-VAV panel. We are going to daisy chain it with the first one, and we will do the measurement of the temperature in the two different places, in the two different spaces, and calculate an average. To do this, we need to know some basic information about the VAV14-IP, the default IP address. We need to know the default credential. So the VAV14-IP comes with the application inside. So those are the credentials. And we need to have at least one of those three tools. We can use the IC Workbench, or we can use any Niagara Workbench, but we need to put any tooling modules inside, or we can use the free of charge IC tool. Today, I'm going to make a live demo on our IC Workbench station, and which contains all of our ISMA modules inside, so we don't have to install any tooling modules. So let's go inside our IC Workbench, and by default, you can find the newest AnyTooling version have also the dedicated service. So we can connect to the station that we have in our PC, and we can go inside the services and find the AnyTooling service. So you can see that I've got two devices, two rows in my AnyTooling service. The first one is the not physical device, but this is the way that we can make an USB connection. So we can connect to any Nano Engine controllers, VAV14-IP or BACnet also, using the USB cable. And we can see all the controllers in our BACnet drivers, BACnet station, with the Nano Engine, with added AnyTooling programming extension. So let's go inside below our BACnet network, and let's establish the connection using the AnyTooling. So we need to add the AnyTooling extension. Just click right mouse button, click the action connect. We are going to use the TCP/IP connection today. So as I mentioned we need to know the IP address, username and credential and password. Right now, we are going to read all the information from the VAV14-IP. So the AnyToolings activate a connection which allows us to read everything from the controllers, the libraries, Nano Engine version, schema, and the tree. So everything is kept inside the controller, and once the connection will be established, the LED changes the color from yellow to green, and then the tree appears. So we can see what is inside the controller right now. So we can do the programming. We will start the programming with adding the second panel. So we will go below the network and we will open the BACnet network. And we will make a quick discover of the devices. So you can see that my first CP-VAV panel, which is just next to the VAV controller, has the status OK, but the second one is still unplugged. So we can make a BACnet discover of the devices to check and discover how many devices we've got on our network. And once the VAV connection will be connected, the CP-VAV panel will be connected, we will find the panel.
So the connection we are going to do now is RG45 cable, which is actually connected directly to another CP panel. We call it smart plug. On every control point panel, we have two RG45 ports. Once the cable is connected, we will see that the CP panel is powered up, and we can actually see all the values, and it simultaneously shares the communication data. So the status now changed from the down to OK.
Exactly. And remember, in the scope of today's webinar, we wanted to read the temperature sensor, so the temperature value. So I've already added to speed up and not waste your time, but we also can discover all those 248 BACnet objects in the CP-VAV panel, because the CP is a very universal wall panel that you can customize for your needs. You can do the commissioning, balancing, and the flow setting from those panels, and everything is available from the BACnet network. So to speed up, I've already added, and now I will go inside below my application, and we created the VAV application in a very simple way. So it may look complex because it's quite complex application built with the 116 data points, but we want to make it as easy as possible. So we divide the logic into the logic diagrams, and you can see we've got the occupancy folder, temperature folder, offset calculator folder, CO2 selector folder. So all those parts of the application were divided into the small blocks. And if you want to learn about the algorithm and logic inside, I recommend to visit the ICDocs knowledge base, where you can find all the description of each folder. So you can find, for example, the temperature folder. The temperature algorithm is described over there. We describe what can be the space temperature sensor, how the measurement work, and we also implement some advanced automatic detection of the available temperature sensor. We provide the dedicated diagrams, how the algorithm works, and all of the folders inside the diagram has its own description on our knowledge base. So let's go back to the temperature selector folder. And what we need to do right now to add the second temperature sensor. We need to add the data point. So just click right mouse button and add the analog data point. Let's name it second panel temperature, because the first one we've got over there. And now we need to make a link between the network point, so the BACnet object from the CP panel, to the analog data point. So we need to go below network, click right mouse button, link mark, and click on the components on our wire sheet, so on the data points on the wire sheet, link from. And now we've got the window to make a linking. This time, because we've got nano exchanging inside, we are going to use the reference slot for the linking, because it transfers not only the value, but also the status of the data points and network points. So in case we will have some problem with communication, we will see the information is directly on the data point. We don't have to go below the network and see what's wrong with the network point.
And it's all real time, right?
And it's all real time, exactly.
So there's no compiling. You don't need to save the application. You just change your application, adjust the logic, and it's all saved directly in the controller. It's all done on the controller on the fly.
What's next we should do? We need to find a dedicated component which calculate the average. We can also do some mathematics, but we've got the dedicated components. So let's go inside the math library and found the average components. So we need to drag and drop it. And then we need to make a link. Right now, by default, the first panel temperature from the first CP panel is connected using the link to the temperature selector. We don't want to have this measurement, so we need to delete this link. Then we need to connect the output from this first panel to the input A into our average component. To input B, we will connect the input from the second CP panel. And on the output, we've got the average. So the output we can connect to the input of the temperature sensor selector. And that's all.
So that's the averaging. Wow, that looked easy. I'm impressed, Tomasz, with that live demo. And if you have any questions to us, we would like to hear from you on the chat, and we are ready to answer your questions. We still have a few minutes. In the meantime, when you ask those questions, we would like to invite you into our next webinar. The next webinar will be on the topic of NanoWeb UI, which is the new functionality available in the NanoEdge Engine OS 1.9, which is going to be released until the end of this quarter. And we would like to kindly invite you. In the summary emailing, you will receive a registration link for the upcoming webinar. And please register and stay with us. You will learn how to utilize the new functionalities that includes the web server, haystack, tagging, and creation of this UI with possibility to use it in a web browser, on a smartphone, or a local HMI. So stay tuned, and we look forward to see you next time.
Thank you.
All right, we have some questions. Mark, how many wall modules can you average of one controller, limited by power?
So we have the power up to 5 wall panels. So we can daisy chain up to 5 panels and make an average up to 5 sensors. But of course, it's BACnet communication. So if you will provide a dedicated power supply to more than, if you want to connect more, you can provide a dedicated power supply and connect up to the BACnet limitations, 110.27 even.
We have a question from Mike. I believe you mentioned that the VAV can be seen on the MSTP layer. Can you elaborate on that some more? So thanks to the server and client function inside the VAV controller, the data points which are exposed can be visible over both the IP BACnet and the MSTP BACnet. So all the points can be also integrated over the MSTP, and our VAV controller has a single COM port for the MSTP connection, which means the smart plug we have on the controller shares the same BACnet. This panel is actually integrated over BACnet. So the limitation would be you either use the COM port for a panel or for the BACnet MSTP integration with a supervisory controller. Okay. So please keep asking questions. We'll be answering them in the Q&A as always, and share together with the webinar summary email.
So thank you one more time.
Thank you very much, everyone, and see you soon.